Okay, graphs of inverse trig functions. Okay, before we talk about the inverse trig functions, let's just kind of review the trig functions, like y equals sine of x. And let's make a graph of that real quick. Okay. And period is, this is just the parent trig function for sine. 2 pi, pi. This is pi over 2 at that peak, and 3 pi over 2 at that low spot. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so we're talking about inverse trig functions. Is the inverse of the sine, y equals sine x, this is a function, right? It would pass the vertical line test. Is the inverse of this function as we have it drawn now a function? We have a vertical line test. For inverses, we have what? A horizontal line test. Does it pass that? It does not pass that. All right? So what we're going to do is kind of restrict the part of the graph, which will be from here to here. This is 1, by the way, and that's negative 1. So we're only going to take a section of it. We're only going to take a section of it and call this part the inverse trig function, or inverse sine function. All right? What's happening here? Oh, highlighter. Ooh, that is a noisy activity. Okay. So, first of all, I just want to make a table of the sine function, and we're going from here to here, right? And you can also kind of incorporate your unit circle a little bit. These angles look familiar for your unit circle? Okay, I did skip pi over 4 and negative pi over 4. It just gets too crowded. Okay, and with that in mind, what's the sine of negative pi over 2? Looks like negative 1. How about sine of negative pi over 3? You guys got your unit circles handy? Negative radical 3 over 2. Check me on that. Negative pi over 6. Sine's negative 1/2. What's sine of 0? Okay, and then I think we go opposites here. 1/2, square root of 3 over 2, and 1. All right. Okay, this is sine of x. I want to go to one of the ways of talking about the inverse. One of the names is arc sine of x. Okay? Another way means the same thing, is that this is for inverse sine of x. This negative 1 exponent type of thing, that's for inverse sine of x. And I don't remember who it was, and I don't know if it was 7th period or 8th period, when somebody said, when they were asking about inverse trig functions, or we said we were going to talk about them, you're saying, someone said, well, is that like cosecant for sine? And that's not the inverse trig function. That's a reciprocal, which is different than the inverse. Okay? So we're not graphing y equals cosecant of x. That's a reciprocal trig function, not an inverse trig function. Just want you to know the difference between those two. So, well, I'm going to just make a table, but I'm going to make my table. I'm going to put the y values here where the x was. And put the corresponding x values where the y was. Inverse, that's what we do, right? Just switch the x and y coordinates around. We got the inverse. All right, so that's negative pi over 2, negative pi over 3, negative pi over 6. Where am I? 0. Pi over 6, pi over 3, pi over 2. Okay. Let's go ahead and grab it. We got a table here. I'm going to be real careful on what I'm doing here. I'm going to put negative 1 here, positive 1 here, give myself some room. And let's see. And scale this. I'm gonna follow. Actually, I'm gonna make this 1, this 2, and this 3, and kind of put these where they would fall, okay? This is negative 1, bless you, negative 2. Okay. Now, negative pi over 2 is negative 1.57. So negative pi over 2 is like right around here. Right? Negative pi over 3, that's a little bit over 1. Okay? Negative pi over 6, that's around 3 divided by 6. That's around negative 1/2, right? A little bit more, but not much. There's 0. And pi over 6. Is everybody seeing that I'm just kind of thinking of the actual value in my head? 3.14 divided by 6. That's around 3 divided by 6, around 0.5, maybe a little higher. So pi over 6, I'll put right around here. Pi over 3 is a little bit over 1, put around here. Pi over 2 is a little bit over 1.5. Put over here. Okay. Now also, I want to consider this. I think if you look this up, this is around negative 0.86, just so I can place it on the number line decently. That's all I'm doing. I still like the exact values, but I want to get them on the number line. This is around 0.86. All right, so negative 1 pi over 2 is right around here. Negative radical 3 over 2, negative pi over 3. Let's see, if this is half, I'd be closer to here, I think. And I'm at what? Negative pi over 3, which is right around here. Negative 1/2, negative pi over 6, right around here. 0, 0. Right here's half. Pi over 6, around here, radical 3 over 2 to pi over 3, right around here, and 1 pi over 2 is right around here. So it kind of goes, twists like this, and then this one kind of twists up like that also. Okay, it is symmetric over the origin. Remember what kind of graph that is? What kind of function that is, I should say? Yes. Okay. Tangent is also, but what would that be called? That's what we had a category for that earlier. It's an odd function. Okay, yeah. So this is an odd function, just like tangent would be an odd function when we restrict it, when we lower it. Okay. All right. Now, the other thing, I do not have this scaled the same. You have 1 here, that's not too bad. If I were to draw, remember y equals x, draw y equals x. This would be symmetric over that. And if I flip this like this over that, wouldn't it kind of look like that? Am I picturing that right? If I flip this over the y equals x line, I'd have something that looks like this. Okay, they are inverses, that's why. Remember, inverse functions are symmetric over y equals x, the graphs of them. All right, that's sine of x. Any questions? All right, let's do cosine of x. We're only going to do sine x, cosine x, and tangent of x. All we're dealing with today, oh wait, I did forget something here. Before we leave sine of or inverse sine of x, we need to talk about, all right, arc sine here. The domain and the range. What's the domain of arc sine or inverse sine? Inclusive, so we'll go hard brackets there. Very good. And what is the range? Correct. Good. All right. I do want you to know this. Okay, and then kind of the shape. All right, now let's do cosine. If I'm graphing just the normal cosine parent function, kind of looks like that. Yep. All right, now let's get her scaled. 2 pi, pi over 2. When I split up period into 4 parts, that's what I'm getting. And negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. This is 1, and this is negative 1. Okay. Again, the inverse, this is, cosine is a function, its inverse is not, but we want to have an inverse function, so we're going to restrict it. Any thoughts where we should do that? Where do you want to do it? Here? Oh, you'd have to stop there. We could do it here. Okay? Any thoughts about what it might be? What is kind of the convention for that? What has been agreed on throughout math textbooks and mathematicians?
Like from 0 to 5?
It is, yes. This is what has been settled on. Okay? Very good. Now, I'm going to try to do this without making the first table, and I may be sorry. But arc cosine x, or inverse cosine x. All right? Now my x goes from 0 to pi, right? I'm going to go 0, so I'm making that the y on this. Pi over 3, no, pi over 6, pi over 6, pi over 3, pi over 2, 3 pi over 6, 4 pi, 2 pi over 3, 5 pi over 6, and pi. Just if I split that up that way. Now, what is the cosine of 0? All right. Well, I got it down to 2. What's cosine of 0? What's the x-coordinate here? 1. Okay. All right. Pi over 6. Square root of 3 over 2. Pi over 3 is 1/2. Pi over 2. What's the x-coordinate here? 0. Okay. 2 pi over 3 is 1/2. No, x. Negative 1/2, right? Negative square root of 3 over 2 and negative 1. Okay, I've got it flipped around. I already did it. Without drawing the first, I just flipped it around for the second one. Is everybody good? Okay. So, this time, my y's, okay, it's not negative at all. So I am gonna draw just maybe this. I'm still gonna go negative 1 to 1. I'll make this 1, this 2, and this 3. Pi will just be right around here, right? Pi over 6 is like right around here. Pi over 3 is just a little bit above 1. Pi over 2 is right at 1.5, a little bit above it. 2 pi over 3. Let's see. I'll double pi over 3. A little bit above 2. Yeah. 2 pi over 3. 5 pi over 6. 15, 2.5, a little above 2.5. If I just use 3 for pi. I got 5 pi over 6, and pi is a little bit above 3. All right? Is that confusing? I want to kind of get them relative to each other in the right place. All right. 1, 0 is right here. This was around here, wasn't it? If this is half, pi over 6, right around here. 1/2, a little above 1. 0, pi over 2. Negative 1/2, 2 pi over 3. This is right around there. Negative radical 3 over 2, 5 pi over 6. Negative 1 is up here at pi. All right, so all right, there we go. Domain. What do you say, guys? Domain. Negative 1 to 1. Same as the domain of sine, isn't it? range zero to pi. Okay. Good. I don't know if there's anything else I want to say here, but is that okay, guys? You kind of just take this, let's see, flip it around, and you can put it, flip it, and then flip it again, and you would have it right here. All right, so that is what the cosine, inverse cosine function looks like. And the last one we'll do is tangent of x. So I got y equals tangent of x. I just want to look at the drawing. I'm not going to go through a table this time, but I do want to look at the a little further parent function here. Remember, the asymptotes straddle the y-axis. It kind of comes up here like this and goes like this for tangent. This is pi over 2 here, and negative pi over 2 here. Okay? I'm just going to do the one period of tangent here. Because if I just stay with this one period that straddles the y-axis, will it pass the horizontal line test? Yeah. If I don't draw any other periods, we're good, right? All right, so let's just draw that period. And then we'll use that for how we get the inverse tangent or arc tangent of x. All right? The drawing then. You know, you remember if we go halfway, we will have that a value. This is negative 1 here. This is negative pi over 4 here. And this is pi over 4 here. And this is 1 here. All right? So, that's going to help me somehow. Okay, I'm going to draw, instead of vertical asymptotes, we're going to have horizontal asymptotes. Agreed? All right, so and this is at pi over 2. This is negative pi over 2. Goes through 0, 0. If I go pi over 4 units, I go, whoops, that's pi over 4. If I go over 1 unit, I would go up to pi over 4. If I go left, I'd be here. So that kind of helps me here. So I'm close to the asymptote. I come through this point, change the curvature of and then go through this point. And that's what that looks like. Let's talk about domain. Oh dear, I may have gotten a little ahead of myself there. What's the domain? Right. So that square bracket is not something we should be using. And then what is the range? Juliana? Okay. Hard or soft brackets? Yes. Those are asymptotes. It's not going to hit this ever. It's not going to hit this ever. All right? Nicely done, guys. Any questions? As far as what I will ask you on Tuesday, I think mostly I want you to know how to write the inverse and what the domain and range of each of these three are. okay? I don't think I'm going to have you graph them. All right? I just spent 25 minutes